in on time, but perfect timing. I got here, got to sleep, got up.
Yeah, some of the sleep you were doing while having dinner with me.
Yeah. Were you on that flight? Yeah. Were you on that one?
I was, yeah.
No.
I thought I saw you on it.
I was on it.
Keep it on rolling and slowly.
Yeah. John, is that the blue sheet in front of you?
Yes.
Is it moving around?
No, he said that it wasn't time yet for the blue sheet to move around, so I've been ignoring it.
So now it is time.
Now it's time.
Reinitialize.
Would you like to sign the blue sheet?
He signed the one. There's two of them.
That's the other one already. Okay. Okay.
Start
Rich
getting-
is here. We can start.
Who's here?
Rich starts.
Who's he?
Guy at the back. Blue shirt.
Yeah. Okay.
Okay.
Okay. Going to start the TXBOF session. We've got a big agenda, so we're going to get moving through some things. The obligatory note well. And let's see if I can. Is this on? Oh. Is this better? Okay. Or would you rather I just shouted? Okay. We're going to get rolling. Obligatory note well. Here's our agenda. There we go. Yep. Sort of fits onto there. Bottom right. Which one?
Oh.
Wow. Okay.
Yeah.
Any thought, feedback? So we've got our note taker, Tony Nadalin, volunteered for that. Thank you, Tony. Oh, well, it's an Etherpad. Mike, would you like to help Tony? Okay. Any feedback on the agenda? If not, I'm going to turn it over to. Let's see.
Interesting.
Yeah.
Yeah.
There we go. Okay. Oh, I bet if I pushed the right button, it would have gone right there. Okay.
So good afternoon. Welcome, everybody. My colleague Dick Hart forgot to mention that he is Dick Hart, and I'm Yaron Sheffer. And this is the transactional authorization BOF. A little bit of background and some setting towards what we would like to achieve here today. So we have a number of proposals with some connections between them that either extend or to some degree redo the Oauth 2 protocol. We ended up having this BOF meeting. This BOF, by definition, is not working group forming. However, we might, as a group, decide that this is worthy of a working group, and then we will move forward in that direction, but not today. We don't have a draft charter. We're not planning on doing any hums. The main goal for today is to see if we have commonality in the room on what the problem is. So if it turns out that we have three worthy proposals, but they're completely unrelated, and there's no connection, no one direction that would serve as a basis for a working group, we will not continue in this format, and each of the proposals will need to find its own way. If we do see that there is a problem statement, there is understanding and consensus about a set of problems in the Oauth 2 protocol, and note that I'm saying problem statement rather than this technical solution. If we do have commonality around this problem statement, then there are several ways we can deal with it. And I could come up with 4 for now. So we could decide to form a new working group around transactional authorization, or we could say this is like the same audience, Oauth has been doing it for a while, this can go back to the Oauth working group, or maybe someone could come up with a non-IETF group that's interested in carrying this work on, or maybe there's simply no interest. In any case, even though you will see presentations about technical solutions, our main focus as a group for today is on the problem statement, on the use cases, and we would like to understand whether this or each of the proposals is a potential extension to Oauth 2, or whether this makes sense as a standalone non-backward compatible protocol. So this will be part of the considerations that we will go through as the area directors and the community work through this decision where to take this work. Questions, comments before we continue? All right.
Okay. Justin. Let's see if I can figure out how to do it.
Stairs are lame. All right. Oh, click. All right. Hi, everybody. And so this is about some of the limitations of Oauth 2, but with a particular focus for the kinds of things that are being addressed by all of the various extensions and applications and stuff of Oauth 2. Now, this has been something that's a topic near to my heart for a while, to the point that I actually gave an entire presentation on everything that's wrong with Oauth 2 at Identiverse in 2018, which is where a lot of my thinking in this space kind of kicked off. That's on YouTube. You can go look that up. I'm not going to go over it here. But basically, the world that we're in right now is that Oauth 2 started out as 2 nice, simple RFCs. They had one job. They actually did it pretty well. But that's not what the Oauth world looks like today. Arguably, in order to make a good Oauth deployment that fits your use cases, you've got to know how to navigate this pile and figure out, like, oh, you know, am I going to need device flows? Am I going to need JOTs? If I'm going to be doing JOTs, there's like 3 different JOT BCPs that I need to understand and figure out how they fit together to do what I'm supposed to be doing here. All of that is stuff you have to understand before you write the application, which is the part that you actually care about. And So there's a lot of issues just with the growing complexity of the OAuth world. A lot of problems with the OAuth protocol come from its overuse of the front channel as a communication mechanism. Now, the front channel is one of OAuth's greatest innovations in that it allows a user to be present and the browser is really flexible, but it's terrible from a security perspective, and there's a lot of limitations on what you can put through the browser. This wouldn't be a problem except that OAuth puts absolutely everything through the front channel, and especially there's the problem with if you're doing one of OAuth's interactive flows, so auth code or implicit, then you have to start everything in the front channel before you can do anything else. So OAuth kind of routes you down that one space specifically. This is enough of a problem in the OAuth world that we've got a whole suite of specifications, some of them conflicting with each other, that tell you how to deal with everything that's in the front channel, right? And some of these still work, some of them don't. And then we've got options in the OAuth protocol that we now realize are really not that good of an idea anymore. Seemed like a good optimization at the time to have an implicit flow that did everything through the front channel. And we're realizing today that there are some very strong limitations to that. The biggest drawback being people see this and see, oh, it's OAuth, therefore it must be secure, and I can just go use it and not have to understand anything else in that pile, which has caused very real world exploits. OAuth is limited around a single resource owner. It is a delegation protocol that assumes that the person using the application is the person that says it's okay to use the application. User managed access gave us a way to talk about a secondary requesting party, but it is enough of a separate protocol, even though it's built on top of OAuth 2, that you don't actually collapse back into the single user use case of OAuth cleanly. We tried to do that when we were writing UMA 2, couldn't quite get all the way there because of limitations of how OAuth is structured. OAuth was built and defined in a static world where you knew the clients that were talking to the resource servers that were talking to the APIs. And by the way, we assumed that everything was all going to be web servers probably, but mobile might be a thing someday, right? It's a very, very different world here. And we've started to address that in the OAuth space with dynamic client registration and service discovery and all of this other stuff. But there's a lot of cases such as ephemeral single page applications and ephemeral native clients that this doesn't really fit for. And we're starting to see cases where we've got ephemeral resource servers that OAuth's models really don't have a good mapping for. So even the ways that we've tried to expand OAuth doesn't quite reach all the way there. There's all of the different issues of token presentation. If you come to the OAuth meetings this week, we're going to be talking about POP and DPOP. There's been a lot of work that was done on token binding. That didn't really work as well as, some people got really excited about it, but it turned out to not really be good for everybody. Scopes are an absolute mess. They're one of the really good ideas in OAuth 2, allowing people to say, these are the slices of my API that I'm going to be able to give you, but people look at it as just kind of an all-you-can-eat buffet, because scopes can mean lots and lots of different things. There's lots of different dimensions, and we're going to be talking about rich authorization requests, which allow us to add some structure to that. But there's more than one way to talk about that, right? We've got a resource indicator, we've got an audience parameter from, if you go back to the POP token drafts. We've got the claims parameter from OIDC. We've got the new rich authorizations requests. All of these are kind of talking about the same type of thing, where it's like, this is the kind of thing that I want to get. And they don't all play together very nicely. This is something that we're actually actively struggling with in the rich authorizations request draft right now. And how does this new structure relate to the existing structure of resource parameter and scopes? It doesn't even talk about audience and claims in that draft yet. We probably will have to at some point, because what we're finding in the OAuth world is this massive Venn diagram of extensions that, like, trying to figure out, okay, when you see the word, the letters AUD together, is this the audience field of a JOT, or is it the audience designator of a POP token request, or is it the resource servers identifier? And if you're using a JOT authorization request, then you now suddenly have a namespace collision issue where you didn't have one before, which we ran into that with the introspection response draft, trying to register a bunch of stuff. Because really, we're basically getting to a point right now where OAuth does its job very well and it's not going anywhere, but we're seeing the cracks around places where it was never intended to do a particular job and it doesn't do those bits very well. We're trying to patch them over with a lot of different things.
Thanks. So in the agenda here, we've got a number of background pieces around current issues, new issues. Torsten, if you want to come on up here. Does anybody have any questions on, do you want to come up, please? Thank you. To ask Justin on what he's talked about here. We'll have a bunch of other time for discussion later on as well.
Yeah, I'm going to be back up at least 2 more times on the stage, so there's plenty of time to yell at me.
And there's stairs at the end of the stage.
Hi, so this is Roman Dinelli. I'm just checking. So what you're saying is we're fielding clarifying questions now only, but we're going to have some time to chat after this background stuff is done.
Yes, thank you for clarifying my clarification.
Yes, I've got all my slides in one deck, and I then dynamically decide where I cut off, right? Okay, hi everybody, I'm Torsten Lodderstedt from yes.com, and I was asked to contribute to this discussion as well. The perspective I'm taking is I would like to talk about requirements that I see in the space I'm working in, which is more around using Oauth for, I would say, more security-sensitive APIs in the space of open banking, the financial industry, strong identity attestation, qualified electronic signatures, e-health, e-government. What I've seen is a common set of requirements that Oauth does not really fulfill today quite well. That could be solved in different ways. We're going to talk about that later on. The use cases I'm presenting are based on my work in the financial industry. So yes.com built an open banking ecosystem, but I also helped a bank in the context of the Payment Service Directive 2 and the European Union to build OAuth-based APIs, and did some work in the cloud signature area, where I helped the Cloud Signature Consortium to adopt Oauth, and also had some discussions with people in e-health and e-government space to just make sure that my hypothesis work for them as well. All right, let me give you an example first. Who here in the room does know what PSD2 means? PSD2, Payment Service. What it means. Okay, the people here in the room that know what PSD2 stands for, please raise your hand. Oh, I knew that would come up. All right, so the Payment Service Directive 2 is a regulation in the European Union that forces all banks, all financial institutions to open up APIs to let third-party access account information and initiate payments. And there are some very interesting requirements that the legislation and the related technical requirements oblige the banks and the TPPs to fulfill. One of them is that, for example, for a payment initiation, a SEPA credit transfer, for example, the user needs to consent to the individual request. And not only it needs to consent to the individual request, the solution also needs to make sure that the link-in between the consent that the user has given and the execution of that payment is really strong. So in the end, the user needs to really consent to the amount, the P, and so on, and all this data need to be carried through and to be enforced at the resource server. This is really huge, because in the past, we just had something like, oh, please give me access to your profile data. That's no longer sufficient for these kind of use cases. So what we typically see is a structure like this. In such a transaction, the client needs to ask to get consent to send money from a certain account to another account. And this authorization data object also contains the amount in the currency. From a technical perspective, that means the AS needs to render a really dynamic user consent screen. So no longer static strings and just a string replacement for that static string value. And you need to also carry that through with the access token. And in the end, this is becoming the scope in a more conceptual sense of the access token. And it's also transactional because the TPP may only execute that payment once. That's, I think it's obvious. And there are more examples. I mean, it could do it twice, right? Access to account information. It's a similar use case, but a bit different. So here, the client really needs to request what concrete actions it wants to execute on what kind of resources. In that case, those are the different account numbers. And the client, for example, might ask for just get access for the balance for that account numbers, but also to get access to the transactions. That could, for example, be a request by a personal finance management software. And it also contains information about how long that permission should be valid. The third example, it's in the arena of qualified electronic signatures. In the European Union, there is I believe, a lot of regulations and directives. And one of those directives is called EITF. And EITF defines a kind of electronic signature that is equivalent to a written signature. So one can, on a smartphone or a computer, create a signature that's legally binding. Clearly, there are really strong security requirements around that. And when it comes to authorization of such a process, the user needs to authorize several things. First of all, what's a certificate being used to create that signature? What documents are being signed? And you typically need to you typically have a hash of the document and not the document itself for privacy reasons. And you also need to explain to the user what documents are going to be signed based on that confirmation. And there are other more technical data. And to sum up, there's an example that looks really familiar, which is OpenID Connect. Also, OpenID Connect has really specific requirements to OAuth when it comes to really privacy by design. Because then, instead of using a scope value and a default claim set, the application really needs to list all the claims that it wants to obtain from the user. And the AS needs to show all those claims to the user, and the access token needs to carry through to the resource server. Those are the client claims that the user consented with. And sometimes it's also required to define some values that must be fulfilled by the certain claims. Here in that example, we have the family name, which is required to be Meyer. Well, what have those use cases in common? First of all, the privileges the client asks for are very, very narrowly defined. And that's typically because of the law or the regulation. And this narrow defined scope must be enforced by the resource server. So the resource server needs to know what the user consented with, what the client asked for. And clearly, because they are so narrowly defined, they are fine-grained and structured, which also makes them more voluminous than a scope value, a traditional scope value. And yes, there are transaction values. We have seen some examples. There are account numbers, there are usernames potentially, there are hashes and so on. This all needs to be carried in the authorization process. And those data can be PII, which means that confidentiality, when those data are being in transit from the client to the AS, that's an important requirement. And moreover, the integrity and the authenticity of those data is a key requirement as well. So, what are the challenges when it comes to implementing these kind of use cases with Oauth? I've split that in two aspects because my proposal is also split in two different drafts. First of all, we have the problem of the transport. How is this data sent from the client to the authorization server? I mean, Justin already made that point. Nearly anything that's really important is sent through the front channel today. And it's sent so in an unprotected fashion. Meaning there is no integrity protection, there is no authenticity protection, and there is no way to ensure confidentiality. Yes, there is a draft addressing that. It's called JAR. Justin, I think you also already mentioned that. So you can sign and encrypt those requests, which makes the request URL even longer. So we have a real reliability robustness problem here when it comes to conveying such amounts of data between the client and the authorization server. And we have a problem with the representation. I mean, I couldn't more agree with Justin's assessment, right? So the scope is just not sufficient because scope was made for really simple static things. Just ask for read access to a profile and not for doing transaction-specific things. There is no structure in the scope. All we were able to agree on was a delimiter between the scope values. That's it. So it's fine for simple use cases. In my personal experience, it doesn't help if there are multiple resource servers that you want to specify scope values for, because you can't really determine the assignment of the scope values to the resource servers, which makes audience restriction really, really hard. And a scope value could also be ambiguous. So in the same way as done previously and in the past by the C++ report, you can just tell me what's wrong with that scope or how you would read that scope. OpenID, email, read. What's the meaning? Anyone have any opinion? Really? I mean, the first two scope values are taken from the OpenID Connect core specification. And the second and third would make sense if you're running an email system.
Right. So
what I did.
Just to echo from the floor here, the argument was that whoever defined that API didn't understand scopes. I would argue that, which is what I think Torsten is saying, you have two APIs where they did understand scopes perfectly fine, and they step on each other. So go back to the 5-dimensional Venn diagram in my last presentation. That's really the kind of space that we're looking at here, where OAuth is no longer about protecting one specific API with one specific authorization server. And yeah, that example.
Thank you for pointing that out. The problem I have is I never worked in an environment where an AS only protected a single resource. I ever have been working in environments where a single AS protected multiple resource servers, so I ever had problems with that structure. So we used scope values for just determine what resource server is access being asked for. But thank you for the clarification. All right, do I have a bit more? 2 minutes or victory or? Okay. Okay. I would like to, before we come to potential solutions, I would like to give you an impression that the problem statements that Justin and I just raised are really relevant. And I will do so by showing you that people try to work with OAuth's limitation by implementing their own stuff, right? So just a selection. If you want to know more, happy to present. So there are two classes of workarounds. The one class is, well, let's invent a new parameter and put something additional that we could not convey in the scope in that parameter. The most prominent example is OpenID Connect, because it invented the claims parameter to convey a fine-grained list of claims with additional requirements, which works well. And protection at the transport can be ensured using signed and encrypted request objects. So that's one option. And then there is another example that I included here in my slide deck. And this is one of the APIs that had been invented in this PSD2 space in Europe. And because everybody's talking about UK open banking on Berlin Group, I took the Polish API. And the Polish API uses an additional parameter called scope details. So in addition to the scope that you can see, oops, there, it also has a scope details object that in JSON format provides more information, a lot more information about the payment initiation request. And since those guys know that this data would potentially blow up the URL, they don't send the authorization request through the browser. They send the authorization request in a post request directly to the AS. From an interoperability perspective, that's a nightmare, but they solved the problem, right? And there's another pattern that one can observe in that space, and it's being used by a lot of those initiatives, which is instead of passing all the data in the authorization request, you set up a resource that contains that data and just refer to that resource. And as I don't know who talked about that, I think it was Brian. It's always about sending by value or sending by reference, right? That could be the heading about those two slides. So in those cases, and you see that on the right-hand side, the client first creates a resource that contains all the data that are relevant for the authorization transaction. It gets an ID, and then, for example, conveys that ID in the authorization request, either as a part of the scope value or, for example, as a part of the claim. So the problems exist, solutions exist. The problem is, can we find a generic solution?
All right, so previously I talked about the things that we've done to try to extend Oauth, and now I'm going to talk about the things that Oauth is proving very difficult to extend or really address. So first off, all of these form parameters, like we are posting form parameters, we are sending things as form parameters in URLs and stuff like that. That is drastically limiting our ability for data description, and the parsability of all of this other stuff. And it's even leading to really weird esoteric questions like what happens when I repeat a parameter which RFC 6749 says I'm not supposed to do, but it's silent on what extensions mean. So extensions do that. And then there's the question of, okay, so now I need to do that and put that into a JSON object because I'm doing jar and I can't have repeated keys. And this all just kind of gets weird real fast. So I would really like to see an actual data language used throughout OAuth and used consistently with consistent data models, all right? This is really the big driving thing that I have that I would like to see us do with future work. We've got so many different extensions that are reinventing the same concepts. Torsten showed, we didn't coordinate our presentations. This is really just this universal of a problem. People are reinventing intent lodging patterns. People are reinventing scope description languages. People are, they keep reinventing these kinds of things. Like, so for example, the device flow and SIBA both have a form of intent lodging. Like you make a back channel call and then you go do something else, and then eventually an access token happens. Pushed authorization requests and UMA kind of do something similar, but in different ways. And all of those are ultimately incompatible with each other. I already talked about the resource audience problem before. And then we've got all of the key proofing mechanisms that are out there. There's also the issue that OAuth was really designed in a very different kind of world. What does server mean anymore? It used to mean an actual physical computer sitting on a shelf somewhere, and that's not the case in today's computing systems. I mean, it could be a Lambda function that's totally stateless. It's a very, very different world, and OAuth has sort of baked in limitations and assumptions about what it means to be a participant in this ecosystem. Now, fundamentally, the OAuth protocol is a delegation protocol. In spite of it being named an authorization protocol, it's fundamentally about getting somebody who has a right of access to say it's okay for a piece of software to act on their behalf. And it does this by very brilliantly getting the user involved, the end user who's using that software involved at the right time in the process. But OAuth assumes that that always happens with a web browser, and people aren't always interacting with systems these days in a web browser, to the point where we've had a bunch of different efforts try to do app-to-app authentication, trying to squeeze that into OAuth. We see people bastardizing the resource owner password flow in order to cram other credentials into the back channel in order to not have to pop a web browser, or maybe they can't pop a web browser for any number of reasons. And I kind of realized when looking at all of these different things that a lot of our different grant types are pretty much about the kind of interaction you can do with the user. I mean, arguably it's about the mode of the client and things like that, but all of that really has an effect on how you can interact with the user. Can I pop a web browser? Can I prompt for a password? Can I display a code on the screen? What can I do to interact? And we put them all as grant types because that was the key extension point that OAuth 2 gave us. So that's where we extended it. Now, since we're talking about web-based interaction, how do you even get the user there? We've got a few different ways to get them there. We've got a few different ways to get them back. And we're already seeing use cases where we want to be able to mix and match these two. So I want to be able to send the user directly to a URL. I don't want to have them type anything, but I have to poll. I can't get a callback response in the front channel. Right, or maybe I can display them a code, but I can get a callback. In OAuth today, if you compare the auth code flow and the device code flow, these are strongly tied to each other because they're strongly tied, again, to that grant, that authorization grant concept, which always felt kind of funny in the OAuth world. But what if I wanted to talk directly to a native app? You know, I'm making a payment and I want my bank's native application to show up on my device. They're both there. What if I'm going to be doing DIDCOM and I've got a wallet that something wants to talk to? What if it's not the current user that needs to do the authorization and I need to go get somebody else involved in this process? Or what if I wanted to do some sort of challenge response system? All of this can be kind of grafted into the OAuth world, but it's a bad fit. It's really not meant to do this kind of thing. OAuth is meant around there being one user with the web browser who is sent somewhere and comes back. And then again, who is the user? Right? Sometimes the client already knows who the user is. Sometimes the client has had the user log in. They maybe are using something like verifiable credentials to that they can actually prove who the user is without getting the user directly involved again. OAuth doesn't give us a good way to do that in the wild. What I have seen done, though, is people using the token exchange extension grant to OAuth, and then when that fails and they need to then they sometimes need to get the user involved, then they will drop back to the authorization code flow or something like that. What if I've already got an access token and I want to trade that for something else? Again, token exchange gets us part of the way there, but what if I want to do step-up authentication based on an existing access token? There's the way that OAuth works with its front channel first interactive flows is not a good fit for these kinds of use cases that people are very commonly wanting to do these days. And if I've seen this combination of the user and client before, then I want to be able to, give them a more clean pass through the system. I don't want to have to open up a web browser and send the user there and send them back just to figure out something that I already know. Right? There are trust models where this makes a lot of sense. I already covered all of that. Annabelle's going to be talking about cases where you have a user and you just need them interacting. You're not even necessarily getting an access token. OAuth is all about an access token, but because it has this really rich user interaction capability, people are using bits and pieces of it to do different things. And I also think that there is a lot that's being done, especially in the IoT space, where you're introducing key pairs between different pieces of software, but we're using these authorization protocols to do that type of introduction. It's not a good fit. It's not what OAuth was meant to do, but it's so close. It's like right next door to what OAuth does, right? Ephemeral clients are a really, really big thing these days. You've got an SPA that spins up. It exists for the entire time that the user is there and then just goes away. OAuth 2 said that, oh, these are obviously public clients because we can't pre-provision a shared secret. We can't have a client secret in them. But we have keying technologies today with web crypto and all of that where we could have an ephemeral key pair that protects that instance for that session. But OAuth doesn't have a good place to do that. We're seeing some progress in Depop, but that's really being grafted into an OAuth world that has a lot of different assumptions, right? We need to be able to bridge these trust models where we have ephemeral things and where we've got sort of long-standing policies of like any instance of this client can do the following things, sort of the more traditional OAuth deployment models. OAuth, what? Not much longer. Yeah, not much longer. So OAuth is a very, very client-heavy system. We hang everything off the client. My idea for positing this entire BOF and all of this was, what if we made the transaction of going and getting the authorization delegation the actual thing that we reify against and hang all of our information and all of our decisions based off of that? What I do not want out of this work personally, people have said that this sounds a lot like we're doing SOAP for OAuth. Please, no. No, it wasn't Tony. Tony wants WS Trust for OAuth, and he's already doing that. I don't want that either, but you know, that's beside the point. No, I don't think that this needs to be transport agnostic. I think we need to embrace HTTP. This is the world that it's in. I don't think that this also needs to be strictly backwards compatible if we're going to be solving this right, and more on that later. And I think that's the end of this deck.
Hi, this is Hank.
There's stairs.
I am very happy that I'm here because I don't know why I'm here. It's just coincidence. And 70% you said I'm a wild agreement with. I have never seen a more concise presentation of my problem with all of this than this here. Thank you very much. Also, I think you would always have to keep in mind, this should not be SOAP. I think this should be on the red topic of it, so you remember not to reiterate the mistakes there. And I'm really sure you're not trying to recreate the soapiness and the foam in front of your mouth you get when you see SOAP. And that is excellent. Also, I think when you say HTTP, you mean CoAP also, when there are extensions automatically. And this is the only thing I'm unclear about. So this is my question.
All right. Justin, Richard, just to respond to that, what I really mean is that if we were to take an approach with whatever comes out of here, the same way that we did with OAuth and ACE, in that we have something that is very strongly tied to HTTP and then gets very cleanly translated to CoAP and stuff like that.
Yeah.
I am fine with that.
Okay.
What I don't want is something that is like, oh, you could put it on email, or you could have this be in a text message or whatever, because it's all self-contained and it ignores all of its transport layer stuff.
Okay.
That's what I don't want.
Yeah.
But if you can translate it cleanly, the concepts and constructs from one side to another, and you say, you know, this is an HTTP header versus a CoAP option or whatever they're called, then yeah, that's great.
Okay, agreed. Thank you.
Did you still have a question, or did you preemptively answer it?
I would have a follow-up question now, if that is fine, or can just go away.
No.
Okay.
You started to say you had a question, and then
Yeah.
Justin kicked in. Yeah.
I was answering, but okay.
I have to think. Oh yeah, life cycle and semantics of token. Yes. Also the strong user binding and then everything else. Demarcation line, please. Well-defined scopes, well-defined application of life cycles wherever it goes. That would be very nice. And basically you said that, but I want to reinforce that.
Was that a question or a request? That's not, okay. Annabelle, all yours.
Okay, hi. My name is Annabelle Beckman from Amazon, reporting or talking about some non-authorization use cases I see for a lot of what we're talking about here. So to start with, let's just walk through some scenarios that I've been thinking about. Don't know if anybody else listens to audiobooks. I do a lot through my Echo. I have encountered this experience in the past. I ask the Echo to buy a book so I can have her play it, and I get this kind of an error message, unable to complete this purchase. And yeah, there's a lot of authorization related reasons that this might be the case, but there are also these other problems that may be behind this error message. My credit card could be expired. Maybe there's an insufficient balance of funds on my account, or some other problem that needs to be corrected that I can't correct through the voice interface of the Echo. And so I have to go to the app, or I have to go to my laptop and open up the browser, go to Amazon and fix up something on my account. There's some process that needs to happen outside of the current context I'm in order to resolve this. Here's another one. I don't know how many of you are familiar with Amazon's Dash Replenishment service, but it's a service that lets connected devices order things like ink or pet food or whatever automatically when they automatically replenish things when the device runs out of them. The way this works is the device at some point in here we have a printer says, hey, Amazon Dash, I'm out of ink. And ideally the replenishment service says, okay, great, we'll place an order. In this case, sometimes, hey, we can't do that for some reason. Just as a couple of examples of why that might happen, maybe the customer has not actually properly configured the system to say what kind of ink they want. Maybe the kind of ink that they selected is no longer available. So again, here we have a case where the end user at some point needs to go to some other context where they can fix up this aspect of their account in order to unblock this process. And here's another scenario, last one of these. Amazon Web Services has a simple email service. It does what it says on the tin. In this scenario, we have the back end of some customer owned service calling AWS SES to send some email message, and for some reason that request fails. Maybe it's failed because the customer actually needs to go through the domain ownership verification process to prove to SES that yes, I really do own AnnabelleBachman.com. So you should be allowed to send email through that domain. Or maybe the customer has paused sending on their account and needs to unpause it. Or maybe they've exceeded their quota, or any number of other potentially non-directly authorization related reasons. So there's a common connection through all of these, and that is that the customer or the end user is operating in this context A, but the problem and the resolution is over here in context B, and we need to get them from one context to another somehow. Essentially, to summarize, how do we direct the end user to another context and back again potentially in the middle of an arbitrary process? This is the problem that's present in all three of the scenarios I just went through. It's also the problem that underlies the authorization task that Oauth is designed to serve. Authorization or delegation, as Justin posited that it really is. It's really just a special case of this problem. We're operating in context A. We need to get the end user to context B to go through some process and then return back. So a couple of interesting challenges that I want to bring attention to this problem before handing it off to start talking about possible solutions. Justin mentioned front channel versus back channel. That concept comes up a lot when we talk about this. But there's actually potentially a lot of different channels involved. And I said 3 or 4. That may not actually be all of them, but those are the ones I could think of when I was putting these slides together. So those are the ones I'll mention. First of all, there's whatever channel the end user has between it and the source context. For example, the Alexa voice interface. That's the channel that I'm operating over when I'm interacting with that device. Another channel is the channel between that source context and the context where the problem occurs. So for example, well, in the Alexa case, it might be pretty simple in the sense that it's the API calls being made from one Amazon internal service to another. In another case, it may be a little bit more complicated than that. For example, it could be the customer's backend service making API calls to an AWS service. And then we have the end user notification channel. That is, how is the end user being told to proceed or being directed to proceed to fix this problem? In sort of traditional, the OAuth world, that is, expected to be the end user through their web browser being directed to an authorization endpoint. In the broader context, that channel could actually take a lot of different forms. It might initiate through an email or a text message. It might actually be over the same context or the same channel as the first one. It might not. It might be initiated by the source context, or it could be initiated by the problem context, which is to say the email could be coming from the OAuth client, or it could be coming from the authorization server, to put it in OAuth terms. And then finally, we have the channel between the end user and the resolution context. Again, if we put it in OAuth terms, this is between the end user and the authorization endpoint, where they're going to sign in and consent or not. That's yet another channel here. And then the other challenge I do want to bring attention to is that traditionally with OAuth, we think of this happening within an interactive end user session, but there's no guarantee that that's actually the case. The problems may be identified through non-interactive scenarios. For example, if in the interactive scenario, those are easy for us to think about. It's every OAuth scenario that people tend to throw out there. The non-interactive scenarios, an example that I just presented was a printer detecting it's low on ink. I'm not interacting with the printer app, identifying that and then telling it to go order ink. That's something the printer's figuring out, in the process of potentially of printing something that I told it to print, or maybe long after the fact. Who knows? I don't know how they build those things. The point is that there's no interactive context immediate where the end user can be immediately punted to some other to a website or something to resolve this. So I think that's the end of my slides. Yep. So yeah, that's we have a number of these kinds of non-authorization scenarios where we need to do this context switch, and particularly as we talk about a transactional authorization, some of the solutions that Justin's going to present, there seems to be a natural overlap between what it's doing and what we need to do for these scenarios. So I'd encourage us to think broadly about this problem space.
Any clarifying questions for Annabelle?
Okay, Anna Beck. So, what? Go ahead.
Per your own comments, focus on sort of how it's supplying how it's solving it, as opposed to, how it's solving the problems rather than the details, right?
Right, yeah, exactly. So the slide deck that is available as part of the materials has a lot of technical detail, which I'm not going to be going into a lot of really deep depth in today. But I wanted to talk about the XYZ project, which I started almost a year ago now. And it was my attempt to basically take a step back from all of these different things that we were doing in OAuth 2 and see what it looks like to not use OAuth 2 itself as the basis for these solutions. I think I hit the wrong button there. Oh well. Anyway, so the thing to keep in mind through all of this is what I'm presenting, unlike what Torsten is going to be talking about and has talked about, this is not intended to be a compatible OAuth 2 extension. The reason for that is that there are a lot of assumptions that OAuth 2 makes that if you step away from those assumptions, it turns out things start to get a lot cleaner really, really quickly. And I wanted to run this down and see what this looks like. Details of this project are on the website oauth.xyz. We have Java and JavaScript implementations at this point that interoperate with each other, which is pretty cool. And no, I didn't write both of them myself. So anyway, I mean, this is the shopping list that I was talking about before. We have a lot of knowledge over the last decade about what works and what doesn't and how the world has changed. And this isn't just a blue sky exercise of, oh, if we were inventing this in a vacuum today, what would it look like? I mean, we really need to pay attention to what works in OAuth 2 because it is an incredibly successful and incredibly widely used protocol, which is not going away anytime soon. So anyway, like I said, it's on oauth.xyz. You can follow along there. Everything in this protocol is all about the transaction. I came up with, or I realized that in OAuth, everything is already transactional. So this is cutting off the titles. If somebody could click on the Chromebook or something in order to make that top line go away. Yeah, I'm not, yeah, I don't, okay, I don't know what I did there. Whoops. Okay. So I'm only going to push this button from now on. All right, OAuth has really always been a transactional protocol, but we've kind of pretended that it hasn't been, and we've kind of hung everything off of the client in terms of what it can do and what tokens have been issued and all of this other stuff. I came up with the idea of making the transaction its own thing, and this is evidenced by the intent registration or intent lodging pattern that Torsten and I have both brought up before. A lot of people have tried to solve this inside of OAuth 2, which means you've got to invent a few extra things. I decided to take a look, what would it be like if we had a protocol that was built around that from the start? All right. So the client starts the AS, it talks to one URL and says a bunch of stuff that it wants to do in this transaction. Resources, again, this is JSON, so we already out of the box have a way to say we've got a rich expression of the kind of thing that I want to do, and I can give you a list of them, you know, if I want to do multiple things here. I want to be able to bind keys to things. We need to be able to get beyond just client secrets. We need to have sort of asymmetrical and potentially also symmetrical, I'm on the fence about that, key bindings for client identification and authentication. So how can I prove that to you? Every time the client sends a key to the server or an identifier of a key to the server, it has to prove possession of it. Maybe it's going to sign the body and throw that in an extra header. Maybe it's going to use the Depop thing. Maybe it's going to use cabbage signatures. Maybe it's going to use MTLS, however that works. But in all of those cases, the client says, here's the key that represents me, and I can prove that I have it, right? Now, the kinds of things that I want to show the user on the consent screen, we need to have a place to put those. I put those in the display field here, but I also need to, I also have an opportunity because I'm posting this in the back channel to tell you what I already know about the user. Maybe I've got an assertion that I've gotten from you previously. Maybe I've got something, a verifiable credential from a wallet that's installed on a side application. You know, there's a lot of stuff that I could tell you about the user in a lot of OAuth use cases today that can help the AS make that decision. I can also tell you dynamically how I am able to interact with the user. So I can take an arbitrary redirect URL, I can display a code, and I can also receive a callback URL. Like all of those are different dimensions that I can communicate at the same time. Now the AS processes all of those bits of that transactional request. Maybe it figures out from that we can already issue a token because maybe this key represents a trusted client for that particular set of resources. Hey, guess what? We just invented the client credentials grant without having a different grant type. right? Or maybe I can give you enough information about the user, like a credential challenge or something like that, that's enough for you to log them in and grant access. And hey, we just invented the resource owner password grant without actually binding directly to that or using a different grant type, right? But in a lot of cases, and this is again one of the beauties of Oauth 2, is the auth server says, I want to be able to talk to the user. Well, this is where XYZ really starts to come into its own, because if we're in a traditional OAuth world, we would have already had to send the user over to the AS in order for the AS to decide it doesn't have to talk to the user. At this point, the AS can figure out, like, yes, I need you to talk to the user. So to do that, go to this URL. And the client goes to that URL. It doesn't add any parameters to it. It doesn't add client IDs. It doesn't add scopes. It doesn't do any of that because it doesn't have to. This interaction URL can be generated specifically for this transaction, and the client just goes to it. We've already cut out a huge swath of issues that OAuth 2 has in the front channel today without having to add extra stuff. It's just built around that. So we look up the transaction, the user does all of their normal user stuff, and we calculate a hash to protect our callback that's based on a nonce that the client sent in the front channel, a nonce that the server sent in its response, and this thing called the interaction handle.
Justin?
Yes?
If
Too
I
much
just-
detail?
Good detail, little more than we need, but I was going to maybe go back to the interaction model. Are you envisioning that there's ways of doing it that are non-web? Per some of the other comments of what other people were saying,
Yes,
where
yeah,
it isn't
that's-
necessarily a redirect because
That's
the
later
client
on.
may not be in a browser.
Yep, absolutely.
Okay.
Yeah, I was gonna go through the web case first because that's the most OAuth-y.
Okay.
And then I've got more.
Okay.
I've got like 72 slides or something. So anyway, the whole idea of this hash is that it connects the three parts of the front channel triangle. So the client's request, the service response, and this front channel response all together in a relatively simple to calculate cryptographic protection. You don't need something as complex and structured as JWS in order to just tie these things together. All right, so the client goes and continues the transaction. It's got a transaction continuation handle that it can use, and it also has this interaction handle that it got from the back channel and the front channel. And then in this call, the client has to prove possession of its key, the same key that it used to start the transaction. It has to present that again, that proof again. And the auth server needs to check that, and that allows us to, even with an ephemeral client that just made up its keys the first time it ever turned on and ever talked to this auth server, you can still protect that to make sure that it's not hijackable, unlike an OAuth public client. So in other words, we're getting a lot of the benefits of Pixie. Yes, I know this is not the same model as Pixie, but there's a lot of overlap in this. And if the auth server says everything's all good, you get an access token. We don't need to go into those. I'm going to very, very quickly skim through this. The handles part of XYZ is one of the more confusing aspects to explain. I'd be happy to go into detail after. The TLDR version is that all of those sections that I sent to the auth server can say, you know what, next time that you talk to me, you particular client instance, next time you talk to me, instead of sending me that JSON object, send me this string, and I'll remember that it represents that JSON object. You could do that out of band with a static registration page, and more on that later though. So you start a new transaction, instead of sending the JSON objects, you just send the strings, and the client still has to prove possession of all of the referenced keys, even if it's not sending the public key directly. If it's sending the public key by reference, then you still have to prove possession of it. An access token could come back with a transaction handle because that allows us to refresh. In other words, this gives us refresh tokens without having to have refresh tokens, because what is a refresh token except a way to continue a previously authorized transaction that the user's already done, right? So one of the things I hope you guys are seeing is that these are all concepts that I didn't invent in this project, but by taking sort of a different slice of things, it drastically simplifies how everything fits together and makes it a lot more consistent with each other without oversimplifying it. Same thing with, we can get back to simple scope strings, which are very useful for developers if you have a very small, well-defined API. The difference here is that each of those strings is defined to expand to one of these objects. Like it is a handle to one of these objects, just like those other handles I said, instead of sending this object, send this string, scopes turn into the exact same construct. which already gives us the type of combinatorics that we're struggling with in rich authorization requests today. It's built in. Now, to Dick's question, other ways to interact with things, say I've got a user code. This one's pretty simple. I send you back a relatively static URL and a user code. You chirp that out to the user. They go with a secondary device, punch that in, interact. Now you're looking up the transaction based on the user code instead of the URL, because the URL is static. So we can't add randomness there, but we've got this user code. We can look up what transaction we're working on and go from there. This is incidentally how people tend to build the device flow today in OAuth servers. Meanwhile, we've got a polling mechanism with that transaction continuation handle. There's a waiting mechanism. You can rotate the transaction handle every time you use it for security. If you want to do a combined URL, well, I realize that you don't actually need to do the OAuth device flow combined URL, because we have a way to say, here's an arbitrary URL that you can go to. I can redirect you to an arbitrary URL. I just can't get you back, right? So that's why it's important to split these two. So I can now send the user to an arbitrary URL, and meanwhile, I'm polling. Now, I also think that there's a huge opportunity for us here to expand this. One of the clients that I'm working with is using DIDCOM messages to talk between agents and back-channel fabric servers and stuff like that. If the auth server can send me a DIDCOM message that I can hand over to my local wallet for processing, that might let me bypass most of the user interaction stuff, because I can just answer those questions directly using the fabric. Or maybe I want to do a WebAuthn challenge. Note, you can't actually do this with WebAuthn today, but Google's native WebAuthn and native FIDO APIs are almost there. So I think that the technology to support this is moving there. We should have a space to be able to do this kind of thing. Give me a challenge, I will sign the challenge and hand it back, right? Identity, I think we can stack on just like we did with OpenID Connect. Aaron Parecki's got a great blog post about that. Just go read that. I'm not going to get into it. I think we can bind tokens in the same way that we're doing key proofing with all of the regular client key proofing during the transaction process. Discovery is an interesting thing because the client only needs that transaction URL to kick off the whole thing, unlike OAuth, where you at least need the authorization endpoint and the token endpoint, and you need those two tied together somehow. We've seen real world attacks based on those getting split up from each other. With XYZ, because the interaction URL is generated and returned directly to the client from the transaction endpoint, you really only need one URL to kick the whole thing off. If you need more than that, George Fletcher and I have been talking about a way for the client to signal, these are a bunch of additional things that I can do, and the server kind of picks from that list and says, you know, all right, so here's what you get to use in the course of this transaction when you're talking to me. So it's a very simple, like one round trip way to effectively do a discovery and registration built into the transaction protocol without adding additional stuff on top of it. These concepts, I think, map pretty decently to OAuth 2. There's a lot of familiar stuff here. It's just sliced up in a different way. So all the key possession that we're doing with XYZ, it maps and in some cases takes directly from existing technologies. My implementation does the Depop header signature thing as one of its options. And I've already gone over most of that kind of stuff. So today, you tell an OAuth client developer, here's a bunch of strings that you put into your configuration in these specific spaces. And send a JSON or send a form post. We're really telling them the same thing. So we need to keep this simple for client developers more than anything. So we're saying, here's a bunch of arbitrary strings that you put into this JSON object and post over to the thing to start the transaction process. There's a whole lot of pros and cons to this approach. You know, like I said, I built it out in Java. Somebody else had built it out in JavaScript. They actually work together, which I think is a good first sign. And I think there's a lot that we can do here. You could kind of make something that looks like XYZ by cobbling together a bunch of existing extensions and proposed extensions, and that's not surprising. But what you get with the XYZ approach is something that is internally consistent and is much more sort of simple and intentionally designed end to end, right? So what I'm asking is, let's go build OAuth 3.
Mic drop? Okay. Yes. Thank you, Jeff. Justin. Question?
How shall I start? While you're making up your mind whether we should start working on Oauth 3, I'm going to talk about baby steps, I would say. So instead of the new disruptive solution, I've been working with the support of some members of this community on solutions that are built on top of Oauth 2 to solve the problem to some extent. I would like to yeah. No, with the clicker, I can also present them. All right. I think there's something wrong with the presentation.
What you do? You messed up something.
No, I did not.
There. Okay. Push the wrong button.
I know. You need to be challenged, and you make it right. Thank you very much. Okay. I'm going to present two drafts. The first one is called pushed authorization requests. One could say that's an attempt to have that first initial magical request that Justin just talked about backported to Oauth 2. And it's basically also a reintroduction of the token, the request token request that we already were familiar with in Oauth 1. So the pushed authorization request is based on work that we have done at the OpenID Foundation. It's an individual draft, and although it's an individual draft, it has 5 authors, which is Brian, Nessa Kimura, Dave Tong from the FAPI working group, Philip Skokan, and myself. The draft basically extends or complements JAR, the JOT-protected authorization request, by allowing to push the authorization payload to the authorization server in advance in a back-channel communication. So in the same way as the, what's the name of the endpoint in XYZ? Thank you. In the same way as a transaction endpoint is used to initialize the transaction, the new pushed authorization request endpoint is used to upload all the data of the authorization request, and then the client gets back something that's sent in the front channel. Since we do want to provide a solution within the existing Oauth 2 world, we are not returning a redirect URI, because the redirect URI is the authorization endpoint. So you see, we're trying to get as far as we could within Oauth 2.0, whereas Justin's proposal is something that's really completely new, but without all the legacy that we have in an Oauth 2 based solution. All right, so how does it look like? I mean, basically, it's really that simple. A traditional OAuth request is made up several URI query parameters. So you just send a GET request to the authorization endpoint. Now imagine if you just put the same parameters in a POST request. Wow, that's simple, right? But it gives you a lot, because first of all, you don't have a size limitation. You just send that stuff backend to backend, server to server, to the authorization server, and you can authenticate the client. And that's something I have really been missing in Oauth 2, because when the authorization request hits the AS somehow can identify the client, but it can't be sure that it's really the client it's talking to, up to the client tries to redeem the code at the token endpoint. So then we changed that, and that also dramatically changed the trust model and the security model. So with the introduction of PAR, we can omit some of the security measures that we right now require clients to use in the security BCP. But that's some way to go. All right, so we simply push that data to the pushed authorization request and get back a request UI. And that's where we then start to use JAR, because JAR has a mode where the client can use a request URI to point to some blob that contains the authorization request data. And that's it. We just modify the authorization request through the front channel to use that request UI. So it's really simple. You just take the data, send it to the backend, get a request UI, and send it in the front channel. And this request UI does not need to really expose the authorization data, because in the end, it's only the AS that needs access to have access to that data. So we could have used an opaque handle instead, but since we wanted to be compatible to jar, we use a request UI. There's a second mode, which allows the client, instead of sending all the individual parameters, to send the signed request object in the post body. And this is, for example, a mode that you can use if you want to implement non-repudiation with application level signatures. So it nicely fits into here. What you get is also request UI. So the difference just lays in the way you push the data to the AS. But the authorization request itself looks always the same. It just takes the request UI. So you see it's somehow similar to what XYZ does here. Just the client knows there is a request UI parameter that they need to add to that authorization request UI. And the advantages are, from my perspective, really significant. Because since we can use transport security now, we've got integrity protection and authenticity more or less free of charge. And we got client authentication, which means in the front-end process, the AS already knows, yes, I'm talking to the legitimate client. And the AS can really early refuse to talk to any client that's not really legitimate and cannot really authenticate or is not authorized for a certain scope, for example. And the migration path is that simple. Since the same parameter, even in the same encoding, are put in the post body instead of the URI request. URI. And there are some other interesting properties of that new draft. For example, we do not need to set up redirect UIs in advance. Because now, since we can authenticate the confidential client, we can register redirect UIs on the fly, which again gives us the capability to put some state into that. Or, and that's very interesting for open banking and other schemes, where you have a central authority where the client registers, but then there are multiple ASs that the client wants to talk to. So the client can dynamically register redirect URI for the different ASs, but use the same credential set that were externally managed. So there's a lot of potential in this really, really small extension. And Daniel Fett believes that is also resistant against mix-up. And that, I think, was the attack you referred to when you said there are attacks that can be launched because we have the different endpoints. In that case, since we are authenticating the client in the first step, we still have to analyze that, but we are pretty confident that also mix-up goes away. All right, parse. Do you want to ask for clarifying questions, or shall I go on?
You've got your 20 minutes to talk about your proposal.
Okay, right. Oh.
10 minutes.
Sorry, you're done?
Go ahead.
Ludwig Seitz. One question. What you presented there with the posts for the authorization endpoint, for the token endpoint, this looks a lot like we're doing already in ACE. Have you looked at the ACE drafts?
If you refer me to into what draft I should look, I will do so.
Okay. I can send you an email.
Yeah, thank you. Okay, next topic. So since we now have the proposal for the transport issues, let's take into how do we convey the rich authorization data in Oauth 2.0. There's another draft, which is called Draft Rich Authorization Request, RAR, that I brought together with Brian and Justin. And it introduces a new parameter to Oauth 2, which is used to carry fine-grained authorization data in, guess what, JSON, in the authorization request. And it can be used in addition or as a replacement for the scope parameter. As Justin pointed out, there is some text around combining those, which is not as simple as it seems to be on first sight. And also would like to point out that the resources, I think that's a resources parameter in XYZ, the resources parameter more or less uses the same structure as the authorization details, or to be more precise, we modified authorization details to use the same structure as XYZ does. How does it look like? I mean, that's intentionally the same example that I gave in my earlier presentation. So it's a payment, and on the left-hand side, you can see the example. On the right-hand side, it's in the end an array of JSON objects, and every of those JSON objects contains the data that are specific to a certain set of permissions or a certain API, right? So the example here is the payment initiation, request for payment initiation, and there are some small extensions to my example. First of all, every of those objects in the array has a type field. So it's possible to have different structures in different authorization objects tailored to the needs of different APIs. That's basically what we want to achieve. So we don't want to have a structure that is one size fits all, because it just doesn't work. As you have seen, identity assurance, electronic signatures, account information, they all have completely different structures. And we want to have a support that API providers can define the structure of the authorization details, and clients can use that to really express their requirements, their expectations, and what they want to get in terms of permissions using that structure. Even though we have defined some basic common elements in this structure, one of them is the locations. You can see that as a third field in that example, and the locations should be used to assign that particular authorization object to a certain resource server. And that's a problem I want to solve for a long time in Oauth, because now you can assign the request for permission to a certain resource server, which gives the ability to later on filter the authorization details objects that you assign to an access token or an introspection response based on the location you want to use the access token at. And it also gives you the ability to request similarly structured but different permission on different resource server. Just imagine you want to get access to a file server you want to get access to files on different file servers. You can use different locations, the same structure in the authorization details object, but different data, obviously. And we have further common elements that you will see when you take a look into the draft. And that's the way it can be used. Basically, you can add the authorization details as a URI request parameter, and clearly, you can also use PAR to send that request parameter in the front channel to the authorization server. But you can also add the authorization details to the request object. In the end, you can basically use authorization details in any place where you use the scope parameter today. And I think the tricky part in the end is not how to represent rich authorization data. The challenge for ASs is to really accept that user consent is more complex and needs to be more sophisticated in the kind of use cases I described in my first presentation. If you have variable dynamic data in the authorization request, then the AS also needs to be able to show that in the user consent. And the user consent is a bit more, is more complex than just asking for access for a certain static stuff, right? So that's in the end the real challenge for implementer. It's not the JSON structure. So the AS uses the type of the object and the content in the authorization data to render the consent, and then conveys the authorization details through to the RS in access token and token introspection responses. I also assume that during the course of the user consent, the user, for example, can select some value that are relevant for that transaction as well. So for example, if you want to issue a credit transfer, the client just might specify the creditor account, and the user in the end selects the debitor account, and you also have to convey that through all the way through to the RS, plus all the claims that the resource server needs to really in the end to perform the transaction. Authorization detail goes together with the resource parameter invented or proposed in the resource indicators draft, meaning that if the client indicates the resource server in the authorization details object in the authorization request, the resource parameter can be used in a token request to indicate where the access token shall be used at. And then the AS can filter down the authorization details that it assigns to the access token. And this in the end gives the ability to really create RS-specific access tokens that are audience restricted. And we, so far, lacked that capability in Oauth. So, a bit of advertisement. I think it's a versatile and also type-safe approach. So what we came up with is a proposal where the way authorization data are being represented can be tailored to the needs of a certain resource server or API. We don't want to have a one-size-fits-all solution because we don't believe that really it's going to work, even though we have defined some common data elements that can be used to address common use cases. And I especially like the capability to really assign the authorization data to certain resource servers and to mint resource-specific access tokens. All right, that's it.
Thank you. Okay, let's see if I can. So now we're into some discussion. I'm going to start off with, we've had a bunch of presentations from people saying, we think there's a problem here. Here's concerns we have with OAuth. Here's some new things we'd like to do. I'd like to hear if there's people that disagree with that or have concerns around that and think, yeah, we don't really have a problem here, so we can balance out our viewpoints. Mr. Jones. I'm surprised Tony's not right up there.
Tony's not helpable. We've already ascertained that. This is Mike Jones from Microsoft. I don't debate the premise that OAuth has become a large set of specifications whose combinatorial usage has gotten to be more difficult as people try to determine what subset to use under which conditions. The fact that we're redoing a security BCP and doing a browser-based apps BCP is indicative of the need for guidance to people for what use cases are solved by which combinations in today's security and identity climate. That said, OAuth 2 is one of the most successful IETF protocols in the identity and authorization space, arguably, possibly the most successful. And it's my sense, not as an engineer today, but as a business person, which is a hat I sometimes also wear, that if we go through the exercise of creating an OAuth 3 without absolutely compelling motivation for doing so, we are splintering the deployment landscape in a way that's probably unhelpful to all. And to the extent that we can solve the problems that are being enumerated, as Torsten started to do, using OAuth 2, possibly with extensions, we know how to write extensions. We know how to write BCPs specifying what combination of OAuth protocols solve the problems. And I would advocate that we stay there. I'll make one other observation. OAuth was designed as an
Mike?
authorization protocol.
So I should have clarified a little more my question. We'll have a discussion as to which approach we want to take. The question is there dissent whether there's a problem? There's there's two different approaches that have been presented around how to solve them, but do you not think there's a problem?
I think the problem is solvable by writing BCPs.
So you agree there's a problem?
Not to the extent that was presented on the screen or on the stage, no.
Okay. You want to clarify that a little more? Which pieces do you disagree with?
Sure. The fact that Justin was able to put up a slide with 20 protocol labels on it is not in and of itself indicative of there being a problem that's necessary to solve. In fact, it may be indicative of we have mostly already solved the problems that have arisen.
Okay, so I'd agree with that if there's specs covering the problem, then, well, those have been solved, which is why I tried to break the agenda into what are the issues that we've solved versus what are new issues. Do you not agree that there's new issues?
There are always going to be new issues.
Okay.
That's not unique to the circumstance where we are now. I'd like to make one other comment, and then I'll defer to the next person. Oauth was designed as an authorization protocol. One of the first things that we had to do as a community was also create an authentication profile of OAuth to enable people to log in, called OpenID Connect. If we would go down an OAuth 3 route, we would have to do the same thing again, or we would be in a bifurcated world where authorization sometimes happen with a new protocol, but authentication happens with an existing one. I don't see the equivalent of an ID token anywhere in the proposals. I realize I'm ahead of the discussion, but
yeah, you are ahead of
think
the
about
discussion,
that.
but Justin did have ID token in his proposal. So,
Okay, thank you.
Roman, do you want to Yeah.
Yeah, if I could, it's Roman Dinelli, ED. I just wanted to kind of jump in the line to talk about facilitating. If we could just split the conversation between there were problems voiced and kind of providing, do we agree that those are problems? Then there are potentially many ways to solve those problems, and we can have that as a separate conversation. But if we can help decompose that, that can help us make some progress here.
Thank you for saying better what I was trying to say earlier.
So,
Go ahead, Tony.
Tony Nadlin.
I'd have been disappointed if you hadn't come to the mic, so I appreciate
I'm
you.
not sure, I agree that there's problems, but I'm not sure how prevalent those problems are, whether these are, the last 5% or whether they're 95. I doubt they're the 95% case, but they may be the 5% case. And I'm not sure that the approach, right? So that's all I'm going to say, because the approaches we'll get into later, but I don't believe that they're that prevalent out there that they need to be fixed.
John Bradley, Yubico, I would agree that they're problems, but that's a sign of success. If nobody uses the protocol, there's no demand and no problems. So yes, we have to continue. I think we need to probably move on to the next step of figuring out what that path or paths are.
Any other comments on whether there's a problem or not? You've already had your shot, but all the people that think there isn't really that much, there's too much ado about nothing here, if you could hum. And the people that think that there's some real problems here that need to be solved that aren't well solved now, hum? All those that didn't hum, hum.
So I will. So I think we heard quite clearly that people believe there is a problem. There was a loud minority as well, but most people did agree that there is a problem we need to deal with.
Make sure to accurately capture that, Tony. Thank you. Okay, next would be what's the right approach? There's, Torsten was proposing things that are extensions. Justin's sort of proposing, let's burn it all down, and if we do, then we can clean up a whole bunch of stuff in something much simpler. Did I paraphrase that appropriately? Okay. Do you want to get views on that? Yeah. So, non-Justin, yeah, we've heard your view.
No, I don't think you have.
Okay.
Because what I'm going to say is I genuinely think we should do both. I don't think Oauth 2 is going away anytime soon. It is wildly successful. It is very widely deployed. I think we should keep patching the holes in the brick wall as we find them. And I think that while we're doing that, we should be building the next system. I don't think they are mutually exclusive, and I don't think that putting our energies into both of them is going to be detrimental to either.
Okay, but don't go away because I'm confused then. If we're solving the same problem by extending Oauth 2 and building Oauth 3, what do we tell somebody to use?
So Tony said they can use whatever they want, and I agree with Tony. Sorry, that was hard to say. Stop clocks and whatnot. But no, seriously, I think that Oauth 3, if we decide to start that, isn't going to be gelled and done for the average developer for a while yet. There's going to be transition, just as there was from Oauth 1 to Oauth 2, just as there was from OpenID 2 to OpenID Connect, just as there is from IPv4 to IPv6, but hopefully not that long. But anytime you have a new version of something that adds new capabilities, that cleans up existing issues, there are going to be people still using the legacy thing for quite some time. There are people deploying brand new SAML systems today where I would argue that generally does not actually make much sense from a protocol perspective, right? There are better systems out there, but people can still use them. And I think that if you are building out something today that Oauth 2 with its extensions works for, use that, sure. Okay. But I think there's a lot of stuff that that doesn't address. And to Mike's previous point on fragmentation, all of these extensions are in fact fragmenting the Oauth 2 world.
Yeah. Okay.
Annabelle Backman, Amazon. This is sort of just a observation of something that I think we should think about as we debate this or make this decision. The people who are building applications using Oauth and using Oauth 2 or Oauth 3, whatever we end up coming up with, are not the people in this room, generally speaking. And so to the extent that we can make things, make the right path the easy path for them to follow, that is a good thing, because they will, people like to follow the easy path, right? They will follow the simple, clear path that's in front of them. Today, with OAuth, the simple, clear path is rarely the actual secure path for their use case. Even with BCPs and everything, we can try and guide people to the right path, but unless it's clear and obvious, they are generally not going to take it. One of the advantages I see behind something like XYZ is there's a lot of opportunity there to make the simple, easy path the secure, right path to follow.
Tony Nadlin. I tend to agree that doing both is probably the right answer. I think there's people that need to continue on with OAuth 2. Their infrastructure has been based upon it, and they need to solve certain cases. So the extensions that we're developing today need to go forward, and this group needs to continue that work. But at the same time, it's been pointed out that there are, these areas that need attention, and it's gotten so complex that no one can understand all the pieces put together. I mean, it's going to take a while to get a cohesive specification to the simplicity point that people can understand it. So it's not going to be tomorrow that this thing will come out. It's going to be a couple years down the road when it comes out, and people, need to continue on today. They just can't stop in their tracks.
Thorsten Lotterstedt. I also support the position to work on both in parallel. I think what XYZ gives us is an orientation, right? Where we could go when we just get rid of all the legacy. So starting a clean slate approach, and with all the experience we have in the community, what could we achieve? Plus, and that's what raw and PAR are, we can backport things from OAuth XYZ or 3 to what we now call OAuth 2.0. That's my position as an engineer. I think that the really difficult part is the message into the market. And we should really be clear about that. What our recommendation is for developers right now. And whether, for example, XYZ is mature enough to go with it in a project. And there's another aspect. Even if we continue to work on extending, enhancing, optimizing OAuth 2, I think we also need to refactor OAuth 2. Refactor, clean up, whatever. I mean, let's face it, with the security BCP, we remove 2 grants and have some other guidance, right? We modify the code to go with Pixie along and so on. So potentially we should talk about whether it's time for updating OAuth 2 in some ways, call it OAuth 2.1 something, right? To also simplify what we have today. Just saying, use that, no longer use that, just as an idea.
Has everyone signed the blue sheet? I see it wandering around, floating in the air. There we go. Thank you.
Yaron Sheffer as an individual. The IPC community went through a similar exercise when transitioning from IEC version 1 to IEC version 2. IEC version 1 was showing its age, it was getting very messy, not as extended beyond its capabilities as I'm seeing Oauth 2 being extended, but at some point it became clear that there needs to be a new version, and in fact IEC version 2 is a complete overhaul of IEC version 1. IEC version 1 systems are still very much out there, and I think it's been 10 years, so there will be a very long transition period. And of course, the more successful the protocol, the longer the transition period. I'm worried about 2 things here. First, multiple parallel work on 2 protocols should be limited. So a 2.1 and a 3 done by the same community at the same time is not a great idea, and maybe BCPs are actually sufficient. Yes, BCPs are an indication that something is sick unwell with the base protocol, but still doing even a minor version is a very large effort, and you could easily get into conflicts between now 3 protocol versions. And the second thing is, of course, feature creep. I'm hearing feature creep already. when I'm listening to this. So again, as a community, I think we will need to give up some of the more obscure use cases in order to really specify as few paths as possible. So it's very hard to measure simplicity, and usually simplicity is being used just to kill the options and the features that you don't like. But still, if simplicity is a value in this proposal, let's focus on simplicity from day one. Thank you.
Philhan Baker. So folks seem to be thinking in terms of adding features as the way to improve protocols. I often see taking them out as being the improvement. And in particular, as a specification's been out there, it accumulates barnacles. And eventually the number of barnacles out there is just too much for people to really implement. And so I don't see that there's any real conflict between extending and reducing. And if you reduce, you want to do that reduction all in one go and not in a series of individual pieces, because if you deprecate individual functions, then it'll never happen. If the only way that you can really signal we're getting rid of the old stuff is if you have a major revision. But that major revision doesn't need to be a complete change of syntax like HTTP 1.1 to HTTP 2. It doesn't need to be that radical. It doesn't need to be a complete discontinuity unless you want it to be.
Hi, Aaron Parecki from Okta. My job is literally flying around teaching people about OAuth. So I have a lot of, I've seen a lot of people struggling with understanding why we are at the point where we're at with this today, which is a lot of jumbled specs, a lot to read. Torsten kind of stole my thunder there with the OAuth 2.1, but my idea with that was basically, let's capture what we do have today in what works in OAuth, which is, extending this core. We've added a bunch. We've removed things through the various extensions and BCPs. Kind of capture that as here is the simplest version of what does work today, with the grants, the extensions that are well deployed, removing things that were not a good idea or no longer necessary, and giving that its own name. The intent there is to give people a simple path of reading, starting with one document instead of trying to navigate their way through a pile of 20. And I think that is sort of how I would want to approach the sort of cleaning up of what we have right now. And at the same time, like Justin was saying, I do think that a sort of rethinking from the ground up is not a terrible idea. And I do think it's still worth pursuing in parallel. But that's I mainly want to just get this point out about let's clarify and solidify what we do have right now that does work, because there is enough there that has changed enough from what we've started 10 years ago. So.
Brian Campbell with Ping. I just sort of wanted to agree with Aaron in the sense that there are a lot of different documents out there. It can be very intimidating and confusing to come to. I also think there's, on the flip side of it, there's a lot of value to the different composability of the documents. You can assemble things for your needs. Sorry, better. I'm taller than Aaron. No offense. There is a valuable side to the number of documents as well, which is that there's composability there, and different needs and deployments can compose those in ways that make sense for their needs. And we're seeing a lot of that both in individual deployments and in larger consortiums and other working groups that are doing profiles of this stuff to do it. I guess I have some concern that going for a full rewrite, an OAuth 3, whatever it might be called, would create a lot of confusion in the marketplace. And when I say marketplace, I mean everything from individual developers to vendors to spec authors, like the whole ecosystem. And while we can talk about doing things in parallel, there is a limited amount of time and attention and resources available amongst all of us. I know I have a hard time just reading and keeping up with the number of specs that are in the few working groups that I participate in, trying to be involved with and give proper attention to a complete rewrite is daunting. I'm not sure I would have the time, and I'm not sure there's really the appetite and the energy to apply to both of those things. And then I think that likely another document at this point would, even if it's an OAuth 3, would just exacerbate that confusion about which pieces of this do I use. Then it's not which of the OAuth 2 pieces do I compose together, but do I use which of those, or do I use this new thing, and do I wait for that? How do they interact? So the old XKDC comic comes to mind. I saw a few smiles, but so I guess I want to be careful in how quickly we jump to taking on the work and realize that there's an impact on the marketplace at wide. And I think we should be considerate of that before we jump into it. And while it's oftentimes appealing to do new work, to set out and solve all the known problems we know about in the last protocol, it sounds interesting, it sounds fun, it's challenging, it's new, but it's a lot harder to start over, correct all the problems that you know about, and not introduce new problems than it often seems like as you go out at first blanch. It's quite a bit more time consuming, more challenging than you might expect. And we would need a lot of attention, a lot of work on it that I don't know we're in a position to really put forth and maintain and do the other work. And I'm sort of rambling at this point, but I think the point maybe is clear.
Hannes, adding on top of what Brian said, some of you who complain about the number of documents have actually contributed, written those documents, and exactly in that document split as it exists today, preferring smaller and more document than bigger documents that have several different things in there, at that time claimed for improved readability and for the modularity that Brian was talking about. So I feel it's a little cynical to now say, oh, we have all these documents and who should read all of them? Adding more documents, just helping developers to read the existing stuff more easily. So I would, next time we have any discussion and someone of you comes along and proposes another document, please keep that in mind. And I have no doubts that even if we start another effort, there will be as many documents as we have today, because this is where we came from in OAuth all along, because the previous solution was so complicated, so difficult to understand. And here are we now a few years later. So I think this is just the nature of the way how successful protocols evolve over time. People want to use them in environments which were not initially envisioned. It's the definition of a wildly successful protocol. And then you obviously stretch the boundaries a little bit. And sometimes you may need to ask yourself, is OAuth really the right thing for the given problem at hand? And do you really need to stretch it that far? Or would it be better to use something entirely different?
Hannes, before you go away, could you go back to the mic? Walk back. I got a question for you. If we were to do both pieces of work, do you think that it would work well to keep them in the same existing working group, or do you think it would be good to have a separate working group? Asking you as co-chair of the OAuth group.
I have no opinion about and leave it totally to the ADs to decide that.
Okay, so you take the fifth. You probably don't even know what that means, but okay.
So as the AD of kind of OAuth, I mean, I have talked with the chairs kind of extensively on what happens if we do it both ways, and we need to have a kind of a broader conversation. And one of the things that in our conversations that came up is we need to be a little more specific to better understand, what are the new things we want to have. And I think the new emergent thing in this conversation here is we would need to be specific as to what gets backported, what's not, and we would need to be a lot cleaner to kind of to really reason about that solidly.
Ben Kadek. So, Brian, I know you said you were starting to ramble at the end, but maybe I could be a little pithy summary and say you're worried about the second systems effect? Like the second system effect where like you try and do the new version of the thing and you get all the bells and whistles and try and do everything and it's just too complicated and it fails because it's over-engineered.
Perl 6.
I was rambling. I'll try to be less rambling now, but yes, to some extent, but more so have some concern about the amount of time and attention available from participants in this and other working groups and the ability to, really just devote the kind of time that's necessary to build a second system protocol from the ground up, and maybe those problems coming in. Try to be less rambling. Maybe just to summarize that we've had sort of two main issues come up. One is the number of documents currently in OAuth. I think while a new protocol is one way to try to deal with that, we could also consider doing some sort of BIS document or some sort of BCP or some sort of roadmap type document. That would be one way to work with that. And in terms of the problems with OAuth, sort of hitting the system limits, hitting the limits of the kinds of things we want to do, there were a few well-articulated shortcomings today. There may be others, but there were a couple that were articulated today and a couple of viable extensions to solve those within the framework of OAuth now. And so from my viewpoint, that's the sort of the incremental path that is pragmatic to follow at this point.
Yeah. We need to cut the line off after, or be quick. Quick.
Mike Jones, Microsoft. I will say that that I do see lots of examples of the community when they see a real problem, such as needing a signed authorization request, creating the solution, deploying it, standardizing it. We need to finish OAuth jar, but that's nearly done. But for instance, in the financial world, the financial APIs in Europe, in Japan, and some of the ANZUS countries are using these extensions to OAuth successfully. Second, I will say that I completely agree with Brian's concern that we all have limited bandwidth as specification authors. To the extent that we're trying to do two or multiple major things at once that are highly interrelated but distinct, we need many of the same people to pay attention to both of them, or we will get unnecessary drift, and even worse, we will find the unnecessary introduction of security gaps and usability gaps because all the right experts weren't reading them.
Annabelle Backman, Amazon. So I think a lot of attention has been brought to the fact that there's a whole lot of different OAuth-related drafts or OAuth-related specs. And that's certainly true, but they're sort of fall into two different categories, I feel. One is the category of additional features for specific use cases that people might need. The other is the category of stuff you need to do in order for your deployment to actually be secure. And I think the big problem today is that latter category, that stack is pretty high. There's a lot in there. And anybody implementing this stuff needs to be familiar with all of that. And some of the reason for that stack being there is in part because of incorrect assumptions that were made when OAuth was designed, or assumptions that made sense at the time but no longer hold.
Annabelle?
Yes.
Sorry, I'm going to cut you off.
Okay.
I need to ask some questions before we end the time. I guess a key question, and Brian's brought that up, reiterated by Mike. Who all would spend time on a new ground-up version? Hands. Okay.
One hand from the Jabber room also.
Okay. My hand was up too as an individual. 2. Do I hear more? Play auctioneer here. 7, 6, 7.
I mean, that's hard though, right? I probably would, but I worry about actually having the time to devote to it in the cycle. So
Yeah, I'm sure more people would if it was going just because they had to, but I'm guessing that a bunch of people are saying I'd rather not. Yeah. Go ahead. Yeah.
So, I mean, so we're out of time. It's obvious we need to keep talking. So, I mean, I think the top line things I heard is there is a number of problems voiced here. There is a recognition that these are problems, and there's a recognition we need to talk about how we would solve those problems. We don't appear to have kind of consensus here for exactly how we would tackle them. There are a number of options kind of presented here in the mic line. There were a couple I think quite, there were kind of concerns about, there are trade-offs with each one of those approaches. And I think next steps are now I'm kind of tossing this out there, is I think we need to continue talking on how we would execute some of this. And that's the future conversation.
So question for the chair, this is Justin. Where should that conversation take place? Because we did stand up the TXAuth list ahead of this BOF to start things off. I know a lot of the people are already on that list. We do also have the Oauth list, which is gigantic. So where should we have that?
Well, given that we're trying to talk about where to do the work and we've started it here, potentially TOX, I would say that we use TXAuth right now to kind of sort that out, and we can make that clear on the Oauth list and in the Oauth meetings kind of as well. So again, what I think we have consensus on, we have a problem. What we don't have consensus on is how to tackle that, and we need to, I think, sort that out.
Okay. Thank you, everybody. We'll continue discussion on the TXAuth. We'll post that we're going to have that discussion on the Oauth, so people in the Oauth group are familiar with the discussion happening on TXAuth.